So for number 10 particularly, this problem sucks because you have decimals and that kind of thing in the problem, and then the graph itself is whole numbers, and so the graph is at best going to be a good guess and not a real graph of what's going on. But I know you can read the problem, and it seems like you have a pretty good understanding about the y-intercept. So just given that that is in slope-intercept 4.95 is our y-intercept. And so the y-intercept of the equation is 4.95, which, if you come over here to where is that? Okay, at best we're guessing, so I'll put that right there. And then graph the equation. Okay, well, we have to go up by 0.05 every minute. And so that means for 40 minutes, what we can do is take that 40 minutes and put it in the equation. So the cost would be equal to 0.05 times 40 plus 495. I hope that you get a calculator to do this junk, because I'm certainly going to do it with a calculator. 0.05 times 40, I think it's 2. It is 2. So that would be 2 plus 495. So at 40 would be at 695. So again, I'm just guessing where the heck 695 is. Like, how are you supposed to do this? Okay. So it looks like for every 40 minutes, the cost goes up by $2. And so for 80, it's going to be $8.95. And you could put that in the equation if you wanted to. You would get $8.95 if you put it in there. Another 40 minutes is going to be $10.95. And then $12.95. You could go through this process for all of those values, 40, 80, 120, 160, and you would get the values that I said, like 8.95, 10.95, 12.95, and 13.95. 8.95, so 4.95, Jesus, 6.95, 8.95, 10.95, and 12.95. But again, I recognize that the pattern was that it was going to increase by 2 for every 40 minutes, and so I just went up by 2 with every 40 minutes that I added to save myself a little bit of time. But again, you could use the equation repeatedly with each of those values to get those points. So if you talk for 140 minutes, what is the monthly cost? I could probably do that. I could probably figure that out just using the pattern, but I'm going to go ahead and use the model how to do the equation to do that. So our cost equation is C equals 0.05 m plus 495. Again, there's no way you're going to have enough room to do this on the paper that's provided. You're going to have to do it on a separate sheet. And so cost is equal to 0.05 times 140 plus 495. So 0.05 times 140 gives us 7 plus 495. Is 11.95 for part C. Okay. Killer whales usually swim at a rate of 3.2 to 3.9 kilometers per hour, but they can travel up to 48.4 kilometers per hour. Carriers, suppose migrating killer whale swimming at an average rate of 4.5 kilometers per hour, distance was traveled. Okay, we got an equation. We need to graph the equation. We need to recognize that there is a y-intercept here. It is just that the value of the y-intercept is 0. And so we are going to begin at 0. And again, this has decimals. It's ridiculous. So I could go up this and go 4.5, 9, 13.5, 18, 22.5, 27, 31.5, 36, and then across the bottom, we would just be doing each hour. So 1, 2, 4, 5, 6, 7, 8, 9. Okay. So anyway, if we did that, it would be 4.5 every hour. So I'll just go like this. And then it says use the graph to predict the time it will take the well to travel 30 kilometers. That's the stupidest thing I've ever seen. Why would I use the graph to do that when my graph only goes up to 9? I would use the equation. D equals 4.5t. The time in this case would be 30 kilometers. So the distance is 30. So again, like you can see over here, right, I could guess, sure, like 30 is going to be like about, I don't know, right there where that red point is, something like that. Like maybe 6.5 hours. Well, why would I do that? Why wouldn't I just use the equation? So we would divide both sides by 4.5. And so 30 divided by 4.5. 6.67 if I was to round it. So about 6.5 hours. That's what I would get if I was to use the graph. A more precise answer is the 6.67 that I got from using the equation. Again, I'm unhappy with the way that most published math curriculum chooses to handle things. I think we do a really good job of making kids hate math by giving them terrible problems like these ones.